Hey guys, welcome back to our channel. Today, we're demystifying the fascinating world of artificial intelligence, or AI. We often hear terms like AI, machine learning, and neural networks. But what do they actually mean? By the end of this video, you'll have a clear understanding of these concepts using simple, everyday analogies. Get ready to dive into the world of AI. First, we'll cover some essential AI general terms, then don't miss the bonus section at the end, where we'll tie everything together and show you how your input data flows through an AI system to create amazing outputs. Let's get started. Artificial intelligence, or AI. AI is a part of computer science that works on making machines smart. It helps machines understand their environment and learn from it so they can make decisions and take actions to reach their goals more effectively. It involves creating systems that can perform tasks that usually require human intelligence. Imagine having a robot that knows exactly what you need. Just say bedtime, and it'll turn off the TV, silence your phone, dim the bedroom lights, and play some relaxing music or your favorite song. How cool is that? Think of a virtual assistant like Siri or Alexa. These assistants use AI to answer your questions. AI is basically that one friend who always knows the answers to your random questions, but never eats your snacks. Machine learning, or ML. ML is a subset of AI that focuses on the idea that machines can learn from data and improve their performance over time without being explicitly programmed. Imagine teaching a child to recognize different types of fruit. You show them lots of pictures and tell them the names of each fruit. Over time, the child learns to identify the fruits on their own, even when they see new pictures they haven't seen before. Similarly, ML algorithms learn from data to make distinctions and predictions. It's like your car's GPS system. Over time, it learns your preferred routes and suggests them without you having to input them every time. Think of ML as your personal assistant who eventually learns that pizza means extra cheese without you having to say it every time. Natural language processing, or NLP, is the branch of AI that helps computers understand and interact with human language, enabling them to read, decipher, and respond to human text or speech. It's like having a translator who can understand multiple languages and helps you communicate with people from different countries. Imagine a customer service chatbot that understands your questions and provides relevant answers. This chatbot uses NLP to interpret and respond to your queries. NLP is like that friend who always gets your sarcasm, even in text messages. Computer vision allows computers to interpret and make decisions based on visual data from the world, like recognizing objects, faces, or scenes. Think of a security camera that can identify and alert you if an intruder is detected. This camera uses computer vision to recognize unusual activities. It's like a photo app that can tag your friends in pictures by recognizing their faces. Computer vision is basically a superpower for your computer, like giving it eyes and a brain. Model and agent. A model is a mathematical representation of a real-world process, system, or concept. It is created using algorithms and training data to make predictions or decisions. A model is essentially the outcome of the training process, where it has learned to recognize patterns and make inferences from data. Example, a spam detection model that can identify whether an email is spam or not, based on patterns it has learned from a dataset of emails. An agent in AI refers to an entity that perceives its environment through sensors and acts upon that environment through actuators to achieve specific goals. An AI agent can be software-based, like a virtual assistant, or embodied in a physical form, like a robot. The agent uses models to make decisions and perform actions to maximize its chances of success. Example, a self-driving car is an AI agent that perceives its surroundings using cameras and sensors, and makes driving decisions to navigate roads safely and efficiently. Big data. Big data refers to extremely large data sets that can be analyzed to reveal patterns, trends, and associations, especially relating to human behavior and interactions. Imagine a huge library with millions of books. Analyzing big data is like finding patterns in the themes and subjects of all those books. Think of a massive grocery store tracking all customer purchases to identify popular products and shopping trends. Training data. Training data is the dataset used to train an AI model, allowing it to learn and make accurate predictions. It's like the practice tests you take before a big exam. The more practice you have, the better you perform. Consider a basketball player on a practicing free throws. The more they practice, the better they get at making shots during a game. Training data is like teaching your dog to fetch. The more you practice, the fewer times you have to run after the ball yourself. Supervised learning. Supervised learning involves training a model on labeled data, where the correct output is known, to help the model make accurate predictions. It's like a teacher showing you the right answers while you're learning, so you can understand the correct solutions. Think of a piano instructor guiding you through a piece of music, showing you the right notes to play. Supervised learning is like having a cheat sheet for life, always knowing the right answer before you make a mistake. Unsupervised learning. Unsupervised learning deals with unlabeled data, where the model identifies patterns and relationships in the data without predefined labels. It's like solving a puzzle without the picture on the box. You have to figure out how the pieces fit together. Imagine exploring a new city without a map. You observe and learn the layout based on landmarks and streets. Unsupervised learning is like cleaning your room without knowing where anything goes. You just have to figure it out as you go. Reinforcement learning. Reinforcement learning is where an agent learns to make decisions by taking actions to achieve rewards, improving its performance over time. It's like training a pet with treats. The pet learns which behaviors get rewards and which don't. Think of a video game character that learns to navigate through levels by earning points and avoiding obstacles. Reinforcement learning is like trying to get your cat to do tricks. You need a lot of patience and a lot of treats. Bias in AI. Bias in AI occurs when the model makes decisions based on biased or unrepresentative data, leading to unfair or inaccurate outcomes. It's like a judge who has only heard one side of the story and makes an unfair decision. Bias in AI is like always picking your favorite child to do the fun chores. Definitely not fair to the other kids. The Turing test measures a machine's ability to exhibit intelligent behavior equivalent to or indistinguishable from that of a human. It's like a robot passing a human-like behavior test to prove it's as smart as a human. Imagine a computer program that can hold a conversation so naturally that you can't tell if you're chatting with a human or a machine. Deep learning. Deep learning is a subset of machine learning that uses neural networks with many layers, hence deep, to analyze and learn from large amounts of data. It's particularly good at identifying patterns and making predictions from complex data like images, audio, and text. Imagine a child learning to recognize different animals. At first, they might only know basic categories like dog and cat. As they see more animals and get more examples, they start to notice finer details, like the difference between a lion and a tiger. Neural networks. Neural networks are computing systems inspired by the human brain's neurons, designed to recognize patterns and make decisions. Imagine a network of roads connecting different cities. Each city processes information and passes it along the roads to other cities. Or think of a network of friends sharing information. Each friend learns something new and shares it with others in the network. Artificial Neural Network, or ANN. ANNs are models based on the structure and functions of biological neural networks used to recognize patterns and classify data. It's like creating a digital brain that learns and makes decisions like our own brain. Consider a group of students working together on a project. Each student contributes their knowledge, and together they solve problems. Convolutional Neural Network, or CNN. CNNs are ANNs particularly effective in processing data with a grid-like topology, such as images. It's like a super camera that not only captures images, but also understands the content, like identifying faces or objects. Think of a puzzle-solving robot that can quickly recognize and assemble pieces based on their patterns and edges. Generative Adversarial Network, or GAN. GANs involve two networks, a generator and a discriminator, competing against each other to improve, used in unsupervised learning. It's like having two artists, one creating fake art and the other identifying the fakes, both getting better over time. Or consider a student writing an essay and a teacher grading it. The student improves their writing based on the teacher's feedback. Overfitting. Overfitting occurs when a model fits the training data too well, failing to generalize to new data, leading to poor performance on unseen data. It's like memorizing answers to practice tests, but struggling with new questions on the actual exam. Think of a chef who can perfectly replicate a specific recipe, but struggles to cook without exact instructions. Hyperparameter. Hyperparameters are settings configured before the learning process begins, affecting how the model learns and performs. It's like setting the oven temperature and baking time before making a cake. Consider tuning a guitar before playing. The settings determine the quality of the music produced. Feature extraction. Feature extraction transforms raw data into useful features for machine learning, making it easier for models to learn from the data. It's like picking the best ingredients from your pantry to cook a delicious meal. Think of extracting the key points from a long article to summarize it effectively. Bonus section: how they are all connected. All these terms are interconnected in the world of AI. AI is the broad umbrella, with machine learning as a crucial component. Within ML, deep learning and neural networks help process complex data. NLP and computer vision are specialized fields using these techniques to understand language and visuals, respectively. Algorithms and training data are the building blocks of AI models, with supervised, unsupervised, and reinforcement learning guiding how models learn. Bias, overfitting, and hyperparameters are critical factors influencing model performance. Data flow. User input to AI-generated output. User input. Let's say you type a prompt to generate an image. Processing. The AI uses NLP to understand your prompt. Model activation. A trained deep learning model, possibly a GAN, processes the input. Feature extraction. The model identifies key features needed to generate the image. Output generation. The GAN's generator creates an image and the discriminator checks its quality. Final output. The AI delivers a high-quality image based on your prompt. And there you have it. We've demystified some of the key terms in AI, from general concepts to technical details, and even explored how these elements work together to create AI outputs. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more exciting content. See you next time.